Hello everybody, welcome to linuxhint.com YouTube channel. In today's video, we're gonna talk about 15 most important C language questions that you could be asked in any of the interview. Okay, so without further ado, let's start. You know the pattern of the videos if you are watching our interview series. All right, so without further ado, we'll start. Okay, so the first question is that what is C and what are some features of it? All right, so the idea is that C is a high-level programming language, and it has header files. It supports file handling and stuff like that. So if you talk about features, okay, that is the most important question, and it basically covers the first part of the question as well, that what is C. So the idea is that C is a platform dependent language. Okay, so it means that on one specific platform you would have one sort of code, and that same sort of code cannot be run in the same way on another platform. Okay, for example, if you're writing a code on Ubuntu, it would have a different way of running and executing the code, while on Windows it would have a different way. Okay, so C, it offers the possibility to break down a large program into small modules basically, and it gives the possibility of a programmer to control the language. Okay, and C comes with support for system programming, and therefore it compiles and executes with high speed when compared to other high-level languages such as Java, etc. Okay, so that was the answer to your first question. So these were like some of the features that I've explained to you. So remember that kinesthetic learning, just take a paper and pen or something to write down and just keep on writing what I'm explaining to you. Okay, so now let's move on to the next question, which is how will you print hello world in C? So in order to print out the hello world in C, in order to write our first program in Ubuntu, what you have to do, that you have to have a GCC installed on your system. So press Ctrl Alt T as we always do. Let me zoom in a little bit. And in here, what you need to do, that just type here GCC and then double hyphen and then version. Okay, so you hit enter and you can see that basically Ubuntu comes pre-installed with GCC. Okay, this is a free software and it is pre-installed in every Ubuntu machine. Okay, so in case if it is not installed, to install it is very simple. Just write here sudo apt get install build essentials. Okay, so you just write this command and it would basically install it. Okay, so let me write here build essentials. All right, so this is the command. So you can see we have GCC here. So now what we can do is that we can create a C program or a file with a .c extension. Okay, and then we would run that .c file with the help of this GCC. All right, so now what we would do would basically go to our desktop here. All right, and here what we can do is that we can create a C program. Okay, C file you can say. So here you can see that we have touch demo.c, and you can open this demo.c in your favorite editor. You can nano it, you can vim it, or you can gedit it as well. Okay, so you can see here that we have demo.c, and basically the basic structure of writing a C program is something like this. You have here hash include stdio.h. all right, and you can see that the colors have changed, right? And after that you have here int main. All right, then you have the body of the main, and inside here, inside main, what you can have is that you can have the code here. Okay, so if we would write here the code, let's say print f, and then we would write here hello world. All right, and then we put here the semicolon. Remember that the semicolon is basically you write it to end the line basically. Okay, so now we'd have here the return 0 that you have at the end of every C program. You have getch function or you use this return 0. Okay, both of them are the same. So now you basically save it, and now you go here and you try to run it. Okay, so the way to run this C program is that you write here gcc, then you write here the file name, which is essentially demo.c, and then you're going to have an output file. So for that you use the flag -o or -o, and then you write here the output file name, which could be anything. In my case, let's say I name it as output. I hit enter and you can see that there are no errors, and if I go to my desktop here, you can see that I have output file here, and this is the demo.c file in which I have written the C program. Okay, so now I would go to my terminal, and in here I would try to run my the output file. Okay, if I hit enter, you can see that it has successfully printed out hello world. All right, so this is basically a basic structure of writing a C program, and that's what we would use. And basically the main function is the main block of the code, and whatever you would write inside here, it would be executed. All right, okay, so now let's move on to the next question, which is question number 3. How will you print out hello world without a semicolon? Okay, how you would basically print it out without using a semicolon. So the idea is that you can do that, but you can do it like without using the semicolon. All right, so how would you do that? You would basically go to your C program, and in here you would just write here if, and you would basically make this function void so that we don't have to return anything. And then you can write here basically printf. All right, and then inside of that you can basically write here hello world. All right, and now basically if you want to, you can define the body of the if you don't want to, that is perfectly fine. So now if we save this program, and now if we go back to our terminal and we try to run our program like this, gcc demo.c, and then we have -o, then we have output, which would be the output binary file. So we hit enter and you can see that there are no errors in our file, in our C program. So now if we run our output file, we hit enter and you can see that it has printed out hello world, and we have done it using, I repeat, using this thing and not using a semicolon. Okay, without the use of the semicolon we have done it. If you want to check that it is the same script, I would write here hello world, this is without semicolon. All right, so we save it, we go back to our terminal and we run this command and we run this, and you can see that it says hello world, this is without semicolon. Okay, so without having to use semicolon, we have printed it out successfully. Let's move on to the next question, question number 4, which is what is a pointer in C and when it should be used? So the idea is that a pointer variable is basically it points to the value of another variable. Okay, and it can basically print out the value of that specific variable. So let me show you how it can be done. You can also have a pointer to a pointer as well, but in this example we're just going to have a pointer to a variable. Okay, so what we would do would go here, and in here what we're gonna do, we're gonna write some code. Okay, so here what we would do, let me just remove this void thing from here first, and now inside here I'm gonna define a variable, let's say a, let's say 45, and then I'm going to basically point I'm going to have a pointer that would basically point towards this variable, which is essentially 45. Okay, so now what I would do, I would write here ptr equals ampersand sign, and then I would write here a, which means that the address of the a would be assigned to pointer variable. So it means that whenever we would be pointing to the value of ptr, it would be basically pointing towards the address of a, and obviously on the address of a, the value of a would be stored. Okay, so after doing that, what you can do is that you can simply print it out and you can see that what happens. Okay, so we know that a is equal to 45, right? So what we would do, would write here printf, and in here we would write here value of a is, and then for integer in C we write here %d, and we do /n for going to the next line, and then in here we put a comma, and then basically we give a here, which means that the %d would print out the value of a. And in the similar way, we would have another print statement that would be a pointer basically, and it would point towards the a variable, okay, at the address of the a variable. And at the address of the a variable, obviously a variable contains 45 as well. Okay, so we'd write here value of ptr is %d /n, and we'd basically close it inside the double quotes, and then I would write here ptr. Okay, so in fact we'd write here static ptr, otherwise it would print out, if we would write ptr, it would basically print out the address that would be like 10012 complex number, something like that, in the memory, the address in the memory. If you would write here static ptr, it would print out the exact value of a, on a actually. So let's just put a semicolon here. Let's write here return 0, and now we save it. We go to our terminal. Let me just clear it. We're going to have here gcc demo.c negative or -o then output. We hit enter and there are no errors, so we have created a binary output file. So now we would basically run this binary output file, and you can see that it says value of a is 45, value of ptr is 45. Okay, so the next part of the question is that when the pointers should be used. So the idea is that the pointers can be used, number one, if you want to get the address of the variable. Number two, if you want to achieve pass by reference in C pointers. Okay, and number three is that if you want to pass large structure, so that complete copy of the structure can be avoided. And number four, if you want to implement the linked data structures like linked list and binary trees, etc. Okay, so in that case you would basically use pointers in C. It's really helpful in data structure. Okay. Okay, let's move on to the next question, which is question number 5. What is a null pointer? So the idea is that null is used to indicate that the pointer doesn't point to a valid location. Okay, ideally we should initialize pointers as null if we don't know their value at the time of the declaration. Also, we should make a pointer null when memory pointed by its deallocated in the middle of the program. Okay, so that was about null pointer. Alright, so now let's move on to the next question, which is question number 6. What are static variables and how they can be used in a C program? So the idea is that a static variable is a variable whose lifetime doesn't end with a function call, basically where it is declared. Alright, so the static variable extends for the lifetime of complete program, and all the calls to the function share the same copy of the static variable that is there. And the static variable, they can be used to count the number of times a function is called. All right, so for example, if you call the function for like 4 times, the static variable would be able to count that this specific function has been called 4 times. Okay, So let me show you that how we'd basically would be able to count the call of the function using the static variable. Okay, so now let's go ahead and let's do a code example, and let's see how we can actually count the function calls. Okay, so in C, remember that we always create a function outside the body of the main function. You cannot create a function inside the main function. Okay, so you would either create this function above the main block or below the main block. Okay, it's your choice. So now we'd have a void function here. Void function means that it would not return any sort of value. Okay, it is not compulsory for that. So now we'd have brackets here, and after having brackets, what we're going to do is that we're going to have here the variable integer, which would be static. And now what we're going to do is that we are going to simply print it out. So we'd write here print f. So right now the function is called 0 times, so it would basically print out like just 1. So before that, what we would do, we would have a logic, something like a logic that would help us know that how many times this function is called, right? So what we would do, would print out this static variable, all right, and we would add it 1 every time this function is called, and then we simply print it out. Okay, so let's say that we write here a equals a plus 1. Okay, so it means that a is incrementing. Okay, initially a would be 0, and when you'd add it, it would be 0 plus 1. So first value that would be printed out, that would be 1 if you would call the function 1 time. Okay, so what we would do would just simply write here percentage d, or we can write here funcs is called times. Okay, and then we have here the value for percentage d, which is going to be a. Okay, we put a semicolon here, and now we go here and we call this function, which is essentially function. Okay, so we call it once, we call it twice, we call it 3 times. Okay, and then what we would do, would write here return 0, and then we save it. We go back to our terminal and we try to run our C code. You can see that there are no errors, and now we basically run our output file, and you can see that it says functions is called 1 times, function is called 2 times, function is called 3 times. So basically you can see that we have printed out, we have basically called this function 3 times, and here the last output is, it says that functions is called 3 times. Okay, so I hope you have got the point. So that was the use of the static variables. All right, so let's move on to the next question, which is question number 7. How would you print numbers from 1 to 20 without having to use loop? Okay, so basically if you are not going to use loop, then obviously you can use recursion. Okay, so recursion is basically a sort of idea that the function would keep on calling itself until and unless we put a condition there, and that condition would basically break the loop or break the recursion. Okay, so now what we would do, would go ahead and we try to write a code. Okay, so obviously this is going to be a recursive function, so we can call it let's call it our loop. Okay, obviously this is a recursion. So now what we would do would basically remove all that code which was already written here, and inside of here this function is not going to return anything, but it would for sure have an argument. So if the values are not negative, then you can use the unsigned integer, or if that is, there is a case of negativity, in the values, then you can use long integer. Okay, so now what we would do would basically write here an argument which would be unsigned integer, and then we call it a variable like whatever, like let's say a. Okay, and now inside the loop, what we're going to do is that we're going to write here the if condition. Okay, if the a is greater than 0, which means that it is positive. Okay, for negative it won't work. And then when the user would give the value, the argument like of the a value, then after that, if that is like greater than 0, then what you're going to do is that you're going to call the function, and the function is going to call itself, and obviously we are going to subtract 1 from that. And then after that, what we would do, we'd write here the printf statement. Okay, so it's sort of a recursion, and it would run until a becomes less than 0. So it would run until like 1. Okay, it would print out 1 but not 0. Okay, so a has to be greater than 0. It cannot be equals to 0. If we put here equal sign, then it would include 0 as well, but we don't have an equal sign here, so this thing is like not included. Okay, so now what we would do, would write here print, and then we write here %d for integer, and then we write here the variable, which is essentially a. Okay, and do not forget to put semicolons after each line. And now what we can do is that we can call this function, and let's see what happens. Okay, so inside the main block, we would call this function, we'd write here r loop, and inside of that, let's say we want to print it till 20. If we wanted to print it till 50, we would have written here 50 as the argument. And one thing before running, make sure that you write here printf and not print. Okay, so now we save it and we go back, we try to run our code by like writing this, and you can see that there are no errors. So now we'd basically run our output file. So we hit enter, and you can see that it is printing out till 20. Okay, 1 2 3 4 5 6 7 8 9 10, and if you want to like print it like in each line separately, then you can add /n here. And now what you can do is that you can run it again. Let me just clear it, and now if you have the output, you can see that it has printed the numbers from 1 till 20. So that's how you can print out from 1 till 20 without having to use loops. Okay, the question number 8, which is what is a data type and how many basic data types are there in C? So if you talk about data type is that specific entity which makes sure that the data that you're giving in the program, it is basically stored in the relevant field. Okay, so for example, integer is a data type, and it has a specific number of bits assigned to the integer data type. And you need to make sure that whatever the value you're putting in, that is integer. So then you would select the integer data type, and that would basically fill in the exact 8 bits for that integer data type. Okay, and in the similar way, you have float, you have string, so they have their own memory assigning things. So in the similar way, you have float and strings, they do have the memory allocation scenarios. So the data type is like storing something which like fits in the container. Okay, so for example, if you have a glass, you cannot fit in a jug inside the glass, right? So you need to make sure that whatever you're going to pour into the glass, that fits in the glass. All right, so that is related to the glass, like for example water, right? So in the similar way, you have basic data types in which you will put the related data. Okay, so let's discuss those basic data types in C. So the number 1 type, it is very common, it is integer. Okay, So integer, you basically use it to represent a number, you use it to store a number inside a variable, etc. So the second basic data type is float, which basically it is used to represent the decimal number. So for example, if you have the value in points like 3.14, if you would give it the integer data type, then in that case it would not store 3.14, rather it would store 3 only. Okay, so if you want to print out that exact 3.14, you have to have a data type float. Okay, you have to use it. The next thing is the basic data type is double. Okay, so double, it is basically used to represent a decimal number with highest precision. Okay, so for example, in float you have up to 2 decimal point 3.14, let's say, but in double you can have up to, you know, multiple decimal points. So for example, 3.14, 3, 5, 6, 7, 8, you know, things like that. Okay, that sort of highest precision or highest accuracy. And then you have the void data type, which has a special purpose and type without any value. And then we have the extension of integer, float, and double, which is long int, long float, and long double, etc. Okay, so this was all about the data types in C. Okay, let's move on to the question number 9, which is what is the concept behind prefix, postfix, increment, and decrement. Okay, so the prefix, let's say we have a variable called as I. So this thing here, this is a prefix increment. Okay, and this thing, this is a postfix increment. All right, and in the similar way, this is the prefix increment, excuse me, and this is the postfix increment. Okay, so now let's discuss both of them. Okay, so if we talk about the prefix increment, then the first thing is that the value stored, okay, in the variable I, okay, and then it gets assigned to the same variable. All right, if we talk about this plus I, and if we talk about I plus, what happens is that the value stored in the variable I gets incremented after the execution of the particular line. Okay, so first the line would be executed and then the value of I would be incremented, but in this case the value of I would be incremented first and then the line would be executed. All right, so that is the slight difference. And in the similar way for the decrement, first it would decrement the I and then the line would be executed, and in this case it would basically execute the line first and then the value would be decremented. Okay, so that is a very fairly simple concept. Okay, now let's move on to the question number 10, which is difference between equal sign and double equal sign in C programming language. So first let's discuss this double equal sign. Basically it is used for the comparison. Okay, it is a comparison operator, and using it you can basically compare the value or expression on the left hand side with the value or expression on the right hand side. Okay, basically you use it inside the if statement, and we'd basically do a simple example for that as well. And if we talk about this simple equal sign, then this is basically the assignment operator, and you can use it to assign the value of the right hand side to the variable on the left hand side. So let's go ahead and let's do a simple example to understand these both concepts. What we would do would basically remove this code from here. We don't need a function right now, so we just remove it. And in here, if you want to assign the value, what you have to do is that you have to use a very simple a simple equal sign. Okay, so for example, we have integer a variable and we want to assign the value to this a variable. How would we do that? We'd write here a equals, let's say 10, and then basically now the value has been assigned, right? So we just write here %d and then comma and then a. Okay, so that was fairly simple. So if we save it, we go back to our terminal. Let me just clear it, And if we try to run our code, you can see there are no errors. We run our output file and you can see that we have 10 on the output. All right, so that's how you basically assign the value using a single equal operator. And if you talk about the double equals operator, so what you can do is that you can basically compare it. If a double equals, let's say 10, then you can basically have here the if block, and inside if you can have a printf statement, printf, and you can do something like the value of a is %10, %d, excuse me, and then you're gonna have here a, or you can have here the else block as well, which would say that else, and we'd basically print here printf, and we'd write here that the value of a is not 10. Okay, so simple is that. We save it, we go back to our terminal, we try to run our code, and there are no errors. We run our output, you can see that it says the value of a is 10, right? So if we just simply change the value of 10 here, we do it, let's say 11, and if we now save it, we go back to our terminal and we try to run our code, there are no errors. You can see that it says the value of a is not 10. Okay, so that's how you basically use this double equal operator to compare the value. All right, so single operator, single equal, was for assigning the value. This double equal is for comparing the value. Okay, let's move on to the next question, which is question number 11, how to generate random numbers in C programming language. So the idea is that the command rand or the built-in function rand is available to use for this purpose. The function returns an integer number beginning from 0. So what we would do would basically, let's say we create like, you know, any of the 5 random numbers. So what we would do would have here a code, and we would have to import or write a new header file here for including the built-in function of the random, okay, of random numbers. So what we would do would have here hash include, and then inside here would have stdlib.h, and yeah, that's it. So after importing the headers, what we would do would go inside here. Let me just remove the previous code. Here I would basically define 2 variables, integer x and integer y. And now what we would do, we would have a for loop here, or a while loop, maybe you can use whatever you like. Would have here I equals, let's say 0, would initialize it, and then we would have here the condition I is less than 5, okay, and then we'd write here I plus plus, or we'd basically increment I, and then we'd basically generate the random numbers, let's say inside the x variable. So we'd write here x, and then we'd write here equals, and after that we'd write here, let's say, you know, I think we just need one variable, we don't have to have another variable, right? So we'd write here x, and then we'd write here equal, and we also need to basically have a data type of integer I, and then we'd write here x equals the function, which is a built-in function random that we would use, and then after that we'd basically print it out. Okay, so we'd write here printf, and then inside of here we'd write here %d, and then we'd have here /n, then we put a comma here, and then we have x here. Okay, so now we write here a semicolon, we come out of it, we write here return 0, and we are all done. Okay, so now it would basically generate 5 random numbers. How do I know that? because of the for loop, it starts from 0 and it ends at like I less than 5. Okay, so 0, 1, 2, 3, 4. So it would run till 4. It would not consider 5 because here we do not have any equal sign. If we would have an equal sign here, it would have considered 5 as well. Okay, and in that case we could basically give the I like value 1. All right, so it all depends upon your logic. So we save it, we go to our terminal, and we try to run our code, and you can see that there are no errors. So we run our output file, and you can see that these are the 5 random numbers that have been generated by our program, and we have done it using C. Okay, we have written a C program. Move on to the next question, which is question number 12, which says, is it possible to store 32768 in an integer data type variable? That is a very tricky question that you could be asked in an interview. So the idea is that integer data type is capable of storing values between negative, let me just write here, it stores value like between negative 32768 and it stores till 32767. Okay, so that is basically the range of the integer. And if they say that you can basically store 32768 inside an integer data type variable in C, then you can say that that to store 32768 a modifier has to be used with integer data type, and therefore long int it can be used. Okay, so long int is basically a modifier, and it would modify the data type, and that's how you'll be able to store 32768 in the integer. Okay, so if there are no negative values, then you can also use unsigned integer as well, as we have done in a function in, I guess, question number 7, right? So in the question number 7 we have used it. All right, the unsigned integer. All right, so the next question is question number 13, and most of the time you were asked question like, what is the difference between local and global variables? So this time we are having a question, what is the difference between static and global variables in C? Okay, so in Java interview questions, in Python interview questions, we have discussed local and global variables in detail. So the same concept applies here as well. Okay, so if we talk about the global variables, they are the variables which are defined outside the function and they can be accessed anywhere in the program. Okay, so they are like global. So the scope of global variable begins at the point where they are defined and lasts till the end of the file of the program. Okay, and if we talk about the static variables or the static global variables, they are basically private to the source file where they are defined. Okay, and they do not have to conflict with other variables in other source files, basically which would have the same value, and that's why the static global variables are like private and they are restricted to the source file, their current source file, you can say. Okay, so that was the answer to question number 13, which is very simple. And alright, so now let's move on to the next question, which is question number 14, which says, what is the difference between memory allocation function and C allocation function or contingent allocation function? So the idea is that we have a whole course, which is the Linux programming interface course, in which we have explained that in detail and everything. So what I'm going to do that I'm going to put the link in the description to that course, which is I think 5 to 6 hours long course, and you can take it and it would basically increase your knowledge regarding C, okay, in way more, you can say, detail. All right, so what we can do is that let me give you an example here, example of the code to basically see the difference in these two functions. So first of all, let me discuss the malloc or memory allocation function. So it is a function which is used to dynamically allocate a single large block of memory with the specified size. Okay. It returns a pointer of type void, which can be cast into a pointer of any form. All right. So the general syntax of that function, of using that function, would be something like this. So let me just write it down here for you. So the general syntax of this function would be something like this: pin pointer, and then you would have like the cast type, which would be, let's say, integer, and then you have the memory allocation function, and then you would have here 100 multiplied by, let's say, the size, the byte size, or you can say you would write here size of, and then inside here you can write integer. Okay, so that would be the general syntax for malloc function. Okay, so let me just write here for memory allocation function. That is the general syntax that we would use. Okay, so now let's go ahead and let's do an example, and then we would come back to the calloc as well, which is contingent allocation function. So first of all, just go to your code, and you have to have two libraries here, stdio.h and stdlib.h. These are the header files in C, so we have both of them. Okay, so now what we would do would have here integer, the pointer integer steric, and then we'd write here ptr, then we'd have here the semicolon as well, and then after that we'd have different variables that we would be needing. So we'd write here integer, let's say a, let's say b, and let's say sum equals 0. Okay, so now what we would do is that we would have the number of elements for the array that we're gonna have. So the first thing here, which we see ptr, this pointer, it would basically hold the base address of the block that we would create. Okay, and in this example, let me do this example first, and then I would tell you that what exactly we are doing. That we are basically creating the, so in this example that we're going to do is that we are allocating the memory using the memory allocation built-in function. Okay, so what we would do here is that we'd basically give any value, let's say 7, and then we'd basically have here a printf, and we would write here basically enter the number of elements. Okay, so we'd write here enter. So here we can write here number of elements for memory allocation, and here we can basically have %d, then we have /n, which would basically take it to the next line, and in here we can have the function, the variable, which is essentially a. Okay, and then after that what we can do is that we can dynamically allocate memory using the memory allocation function. So what we would do would use the same syntax that I have explained to you earlier. So we'd write here pointer, then we'd write here equal sign, and then we'd have here integer, the typecasting that we would do. So after that we'd call the memory allocation function, and inside memory allocation function we'd basically multiply the elements, which is essentially a, and then we'd have basically the size of function, which is also a built-in function, and then we would have here integer. Okay, so now we'd put a semicolon here, and obviously now we need to check if the memory has been successfully allocated by memory allocation or not. So in case if it is not successfully allocated, then we can print an error. Okay, so how would we know that? That is very simple, that if the pointer is like null, then in that case the memory has not been allocated, and if the pointer is not null, then the memory has been allocated successfully. So what we would do, would write here if, and then we'd have here the pointer, and after that we'd use double equal sign for comparison, as we have discussed earlier in one of the questions, and then we'd write here null. Okay, so if it checks it, if that is null, in that case it would basically print f, would basically write here memory allocation has been failed. Okay, you can write here has not been successful or something like that, and then you can basically have here /n to basically move on to the next line, and here you can basically have the exit. Okay, you know, if the memory has not been allocated, we do not want to execute this code further, we just want to exit right away. Okay, so you can have exit 0 or exit 1. Okay, they both of them are same. So otherwise, if the memory is like not allocated, oh excuse me, if the memory is allocated successfully, you want to just write here the else statement, that memory has been allocated successfully. Okay, so you write here printf, and you're gonna write here memory allocation has been successful. Okay, so you write here a semicolon, you write here /n to go to the next line, and that's it. Okay, so now if you want to print out the elements that you have basically assigned, then in that case you can also do that, but I think that is pretty much it. So now if you want to basically print out the elements of the array, you can also do that. You can do that by basically inside the else block as well. So what you can do is that you can do it using for loop. So you would write here for, and then you would write here I equals let's say, let me use here b, actually the one that we have defined there. So I is basically a convention, you can say, inside the for loop. So we'd use here b, and then we write here b less than a, and then we increment the b, and after that what we would do, would have here brackets, and inside these brackets we would have a code here. So we'd write here a pointer, and then we would basically have brackets, and then we would have I here, and then you can write here equals I plus 1. Okay, so yeah, that is the for loop. And then you can basically also print out the, so here you are basically getting the elements of the array, and if you want to print them out, you can also do that. So for that you would just simply come outside the for loop, and in here you would write printf. Okay, and you would write here the elements of array that we have assigned are. Okay, and then you can basically have here /n as well. All right, and after this print statement you can have a for loop, which using which you can basically print those variables or print those elements one by one. Okay, so you can have here for loop, so you write here for, and then you can write here b equals 0, and then you can have your semicolon, and then you can use the same condition, b is less than a, and then you can basically increment b. And after that, inside the body of the for loop, what you're going to write is that you're going to write here the statement to basically print out, okay, the values. So you would write here printf, and inside this printf you would write here percentage D, and then you would have here let's say a comma here, and then you can have here comma, and we have the pointer, which is essentially ptr, and we can pass the value through it. Okay, so we put a semicolon here, and now we come outside of the for loop and the else block, and we have a return value here. Alright, so that was the code. Put semicolon here. We forgot to put semicolon here as well. Oh, excuse me, I just have a habit of like writing I here. You know, the value of the loop here is B, so we would be writing here B. The idea is that when you're programming, you're a programmer, you use I often in the loops. So this is very common to forget about writing any other variable. If you have used, you basically would use I often. Okay, so do not make that mistake. So now we'd basically run our code, and you can see that there are no errors. And now if we basically go ahead and we run our output, you can see that it says the number of elements for memory allocation, they are 7, and the memory allocation has been successful. The elements of array that we have assigned are 1 2 3 4 5 6 7. Okay, so that's how you basically assign the memory using the memory allocation function. So now let's discuss the calloc, which is contiguous allocation. This is a function which is used to dynamically allocate the specified number of blocks of memory of the specified type. Okay, it initializes each block with a default value, which is essentially 0, and in here we have a syntax which is slightly different than the memory allocation. Okay, so what we would do, would use the same code, would just make a few of the changes. Okay, so what we would do, let me just write here the syntax first of all. So for calloc or contiguous allocation, you would have a syntax something like pointer equals, and then you would have here steric float. Okay, and then you would have here the function that you would call, and then you would have here a value, let's say 10, and then you would have here size of float. Okay, previously you were basically multiplying it. In this case you just put a comma here. Okay, and you have a value separately. So now what we would do, would use the same code example that we have done previously. All the code would remain same except here where we are calling this function. Okay, so instead of like having malloc, would have here calloc, which is contiguous allocation, and here you can have anything, like you do not have to have like float here. Essentially we would keep it integer, and then instead of having a static here, we just put a comma here. Okay, and we are all done. So yeah, I think that is pretty much it. So everything would remain the same. So in this way you can assign the memory contiguously. And now if we save it, we go back to our terminal. Let me just clear it, and if we run our code, you can see there are no errors. And if we run our output, you can see that we have assigned the memory allocation has been successful as well. So let me just change the values, like let's say from 7 we change it to, let's say, 10, and now let's see what happens. Okay, so now if we basically save it, and if we go back, we try to run our code, there are no errors. We run our output file, and you can see that the memory allocation has been successful. You can also write here that contiguous memory allocation has been successful. You know, it would be correct either way. So I hope you have got the point. I have tried to explain this question in detail. Also, we have explained that question in our 6-hour tutorial, which is like programming interface long course. So we'll put the link in the description to that as well. And now let's move on to the last question, but not the least one. and that is question number 15, which says write a program in C to swap two numbers without having to use a third variable. Okay, so that is a very tricky question that you could be asked in any of your interview. Okay, so how would you answer it? So the idea is that with using the third variable, it is very simple. Okay, so if they have told you, or if they have asked you to do that without using the third variable, then it would be a little bit tricky. Okay, so let me show you that how you can basically swap the two numbers or the two variables without using a third variable. So let me just remove all of that. Okay, all this code that actually what I'm gonna do is that I'm gonna put this code in the description as well, maybe, so that you can you have easy access to it. Okay, so let me just save it somewhere. So we just remove this whole code, this entire code, and now inside this main function we are going to write a code in which we would basically swap two variables without having to use the third one. Okay, so what you would do, let's say that we have two integer variables, x let's say 10, and we have y, which is let's say 20. Okay, and in here you can write here before swapping. Before swapping, we can have here x equals %d. We can also have y equals %d, and then we can have a comma here, or we can have here /n. We put a comma here, and then we write here x, and then we write here y. Okay, and before that we basically write here the double quote. Okay, and we have a bracket here, we put a semicolon to end the line, and after ending the line, what we can do is that we can have here, we can do some math basically to swap these values. So what we can do is that we can do something like this: x equals x plus b. Okay, and what else we can do is that we can do something like this: x equals x plus y. Okay, and what else we can do is that we can write here y equals x minus y. All right, and then we can have here x equals x minus y. Okay, so here we are doing essentially we are using a logic to basically subtract different values from them. So now let's go ahead and let's see that what happens and if we were successful in basically swapping the value without using any third variable. Okay, so we'd go here, we'd basically print it out, we save it, we in fact here we need to edit it a little bit. We write here after swapping instead of before swapping. Okay, so now we save it, we go back to our terminal and let us just run our code. You can see that there are no errors, so we run our output file and you can see that before swapping it was x equals 10 and y equals 20, and now it is x equals 20 and y equals 10. So we have swapped them successfully. So now let's see the logic that how we actually have done it. So if you basically do once like this, x equals x plus y, so now the value of x would be let me just comment it, x plus y would be 30, right? And if you like do something like y equals x minus y, right, so that would be essentially 30 minus 20. All right, so now the y would have the value 10. Okay, so now it has been swapped successfully, right? And if we talk about this thing here, so the x, it still has 30 in it. So what we would do, would write here 30 minus y, which is essentially the value of y is now 10, right? So after that, what we would have the value of x would be 20. Okay, so that's how it works, and that's how before swapping the value was like x was equal to 10 and y was equal to 20, and after that it was like x was equal to 20 and y was equal to 10. Okay, so I hope you have got the point, you have learned something new, you have enjoyed this video. For written articles, you can always visit our website linuxin.com, and if you want to give us any feedback that how we can actually improve our videos and how we actually can improve our content, make sure that you comment below and let us know. And as I have told you, for written articles, you can visit our website linuxin.com. Thank you so much for watching.